Assalamualaikum warahmatullahi wabarakatuh. My name is Abuskorni bin Yusuf. So I will present our group assignment, Gear Train. So this assignment is completed by our member group, Muhammad Aziz bin Muslim, Muhammad Nazran bin Jihad, dan Muhammad Aziz bin Bakar, and me, Abuskorni bin Yusuf. Okay, Gear Train. Gear train is a combination of gear used transmit motion from one shaft to another. So there are different type of gear train. The first one is simple gear train. Simple gear train consists of two or more gear that are connected to transmit mechanical power from one gear to another. The gear in a simple gear train are arranged in a linear fashion, with each gear being connected to the next gear by a shaft. And the second one is compound gear train. Compound gear train is a system of gear that use multiple set of gear to transmit power and motion between different axes of power point. The third one is riveted gear train. Riveted gear train is a type of mechanical system that use gear to transmit motion from one device to another. And lastly, planetary or epicyclic gear train is a type of mechanical system that consists of multiple gear arranged in a specific configuration. As is uses of gear train. First, automobile for automotive part, mechanical clock for wash. Next, in almost any mechanical tool, such as a saw, a drill, a lathe, or a milling machine. Next, a computer printer or scanner, or a copier. And last, some vacuum cleaner, floor sweeper, and so on.
Okay, I will continue the slide. This is the simplest type of gear train for conveying motion from one shaft to the other. As the name implies, all of the gear axes stay locked in position with respect to the frame, and each gear is mounted on its own shaft, which is a distinct feature of this type of train. A simple gear train is one that has only one gear on each shaft. For compound gear train, compound gear is a number of gear fixed together. Consequently, they rotate at the same speed. An example can be seen. The gear that make up a compound gear usually differ in size and have a different number of discs. This is useful if there is a need to speed up or slow down the final output. For the example, the output speed will be faster than the input speed. And the last type of gear is planetary gear or epicyclic gear train, also known as planetary gear set, consists of two gear mounted to that the center of one gear revolve around the center of the another. A carrier connects the center of the two gear and rotate the planet and sun gear mesh so that their pit circle roll without spin. A point on the pit circle of the planet gear traces an epicycloid curve. In this simplified case, the sun gear is fixed and the planet gear roll around the sun gear.
So next, for our design of gear system, our team have chosen a dual clutch transmission system. So the DCT system shifts gear faster than regular automatic gearbox system. For our design, we choose to improve on the efficiency of the transmission. This can be achieved by using gears with a higher tooth count, which reduce the amount of sliding friction between the gears, and by using materials like a lower coefficient of friction such as ceramic or diamond-like carbon coating. We also choose a 6-speed gearbox system. Next, this is our gear train design. We use 6 driver gear and 6 driven gear, and each gear have different sizes as well as number of teeth. So on the first gear, the driver gear have 10 teeth while the driven gear have 55. In the second gear, the driver teeth have 17 teeth and the driven gear are 45. At the third gear, the driver gear have 22 teeth while the driven gear have 38. And on the fourth gear, the driver gear have 30 gear teeth and on the driven there are 30 as well. So and next the at gear 5, the driver gear have 36 teeth and 25 at the driven gear teeth. And lastly at the sixth speed, the driver gear have 40 teeth and the driven gear have 20. So next, for calculation, we can calculate the gear ratio of each gear by using the formula gear ratio equals driven gear over driver gear. So for example, in our first gear, the gear ratio is 5.50. We can get this from dividing the driver driven gear over the driver gear. So yeah, on the second gear, we can get that the gear ratio is 2.65, while in third gear, the gear ratio is 1.73. In the fourth gear, the gear ratio is 1, while in fifth gear, the gear ratio is 0.69, while in the sixth gear, the gear ratio is 0.5.
Okay, I will continue with the pros and cons of gear train. For the advantages, firstly, by using gear trains, large velocity ratio can be obtained with minimum space. Next, gears are mechanically strong, so higher loads can be lifted. Gears are used for transmission of large HF. They are also used for large reduction in speed and for transmission of torque. For the disadvantages, they are not suitable for large velocities. They are not suitable for transmitting motion over a large distance. Next, due to the engagement of two wheel of gears, some part of machine may get permanently damaged in case of excessive loading. And lastly, they have no flexibility. Next is discussion. To achieve desired speed or torque, a change of gear ratio is needed. Gear ratio expresses relationship between a driving gear and driven gear in a system. A system with a small driving gear than the driven gear will increase torque and will decrease the speed. A system with a bigger driving gear than the driven gear will increase speed and decrease torque. By adjusting the gear ratio into a real value, it can ensure the gear system runs smoothly. As for conclusion, designing a gear train requires a combination of mechanical engineering principles, material science, and computer-aided design and manufacturing techniques. We know how to explain and convert the dynamics and mechanics machines into engineering practice. Then, by following a systematic and methodical approach, it is possible to develop innovative and effective gear train designs that meet a wide range of power and torque transmission needs.